Okay, this is 4-1 for Algebra 2. This is adding and subtracting polynomials. These are pages 353 to 357 in your consumable textbook. If you're going to do the paper assignment, it's pages 358 to 362, numbers 1 through 4, 6 through 12, 14 through 16, and number 18. So that's all those numbers between those. Okay, so we're going to look at adding and subtracting polynomials. First thing you need to know is a polynomial is any expression where you have a number times a exponent, a variable raised to any exponent, and then all of the numbers and variables added up all the way back to a constant. So it could be a various combination of those. And each term of that polynomial is called a monomial because it's one single term. The degree of a monomial is the sum of all of the exponents of the variables in that, and I'll show you that in here in a second. The degree of the polynomial is the highest degree monomial, so whatever's the highest degree, and that's what you always want to find first. The leading coefficient is the number in front of the monomial that has the greatest degree. So identifying some monomials. Out of these choices, x cubed, a squared plus b c 12, and 76 are monomials because there's no adding or subtracting going on there. Multiplication is fine, but adding and subtracting can't happen. So if it's a monomial, so x cubed, 76, a squared, b, c to the 12th. Non-monomials or polynomials is when there is going to be some adding or subtracting going on. So we have a y plus 3x squared minus 5y cubed plus 10. Because we said plus and minus, that is a polynomial. So that is an example of a polynomial. Okay, to identify the degree of the monomial, we look for the degree on the monomial. So the exponent on the monomial in this case is 3. The sum of all the exponents is 2 plus 1 for the b plus 12 for the c, gives us 15. And then 76 doesn't have a variable, but if you think about it, it really does. It's x to the 0 because x to the 0 is equal to 1. So the degree for that one is x to the 0 or 0. That's going to be your degree. Anytime it's a constant, the degree is 0. Okay? Identifying the polynomial, all of the pieces of it is y, 3y squared, negative 5y cubed. So that minus sign becomes a negative, and then positive 10. Identifying the coefficient is the number in front of each of the variables. So remember, anytime there's not a number, it's actually a 1. Number 3, negative 5, and 10. And again, 10 is 10x to the 0. So you can remember, if you're trying to remember why is 10 always the constant always last, because it's technically x to the 0 power. Identifying the degree, we're going to look at the variable, the degree on each one of the variables. So if there's not one written, we add in a 1. Y to the second power, y to the third power, x, y to the 0 power, so it's 0. Okay, now we want to rewrite all of ours in power order. So we're going to find the one that has the highest power, which is 3, and that gets written first. Sorry, that was a misprint. Then we go to the next highest power, and smallest power. And then we want to know what's the leading coefficient. Well, it's the number right in front of the biggest power, so negative 5. Okay, so there's a couple of ways that we can do adding. There's the stacking method, which is very much reminiscent of just adding back in when you were in elementary school. So 140 plus 27, you would just do that and say 0 plus 7 is 7, 4 plus 2 is 6, 1, and you get it. If we had to do, so that's really what you're going to be doing here. You're just basically matching up, but in this case, we're instead of matching 0 and 7 both being in the ones place, we're going to match up the variables to make sure that those are the same, x squared and x squared, x to the 4th and x to the 4th. Anything that doesn't have it, we can add in a 0x to the 3rd, 0x, and plus 0. Okay, just so that we can fill in all those pieces, and then it's just a matter of adding. 5 plus 3 is 8, negative 1 plus 0 is negative 1, 4 plus 6 is 10. 0 plus -1 is -1. 2 plus 0 is 2. The other method is called side by side or matching like terms. And there's a couple of ways to do that. You can do it how they're explaining it, where you take and group your like terms, or you can underline things that go to the same. So I see a x to the fourth, x to the fourth, x cubed, x, and then triangle is the constants. This method works really nice if you don't have a lot of room, but it is kind of messy. I personally use the stacking method all the time. I think it's a lot cleaner and it's a lot easier to keep everything lined up. Excuse me. So looking at number 3 on our your turns, I've worked that one out on the paper and I've given you the step-by-step of how we would do it. So I'm going to use again the stacking method. So our first step is we want to rewrite the first polynomial set, or the longest one in this case, in descending exponent form. So our biggest exponent here was 7, so that would be that whole term, including the negative, has to be brought down. Then we find the next highest, and the next highest, next highest, and the next highest. Make sure you take the negatives, the minus signs, with their coefficients. So if there's a negative sign in front of it, it comes down with the number. Then we're going to rewrite our second term below the first one, matching up our exponents. So x to the third, x to the third. If you want to think of it this way, think of the terms as being the x cubed, x to the fourth as being different team colors. So this is like varsity, JV, ninth grade team, the parents, and then the cheerleaders. They're all different groups. They wear different costumes. They wear different t-shirts. So think of it this way. X to the third is a t-shirt being worn by -2 and 11. Now we're putting them in the same group, and when we add down, they still have to wear the same t-shirt. They both